I will now show you how to make a jelly-like slime. But before you start this experiment, it can really be nice to ask your students what they know about slime. Maybe they've made slime themselves, and in some case, how did they do that? And you can also ask what slime really is, and try to make them realize that it's a kind of liquid that is running very slowly. And what's common for all liquids? Well, they have a constant volume, but they can change shape after the container or the circumstances they are in. Okay, we will make a jelly-like slime from alginate, which is an extract from seaweeds in the ocean. And actually this jellied slime is used in many types of foods, etc. And it's organic and absolutely non-toxic. It can even be used in candy. So it's really safe to work with. And I started to prepare the solution with alginate yesterday because it really takes a lot of time to dissolve it. So I suggest that you prepare the alginate the day before you start the activity. And what you do then is to take 100 milliliter of hot tap water, and you take 1 spoon of alginate into each beaker, and you make your students stir for maybe 3 minutes. They can take turns. They work in pairs, so they can take turns. So maybe you should increase till 4 minutes, so they have like 2 minutes each. And then you can just name the beakers and leave them with some cover here to prevent evaporation. It will be completely dissolved the next day. This will give you a much better quality on the jelly slime you're about to make. So this is my suggestion. The other solution you need is calcium chloride dissolved in water, because this slime now consists of, or this alginate solution is made of long, narrow molecules, and to change this into slime, they must be tangled together. And that's what happens if we combine them with calcium chloride. So I will now take 100 milliliter of, again, hot tap water into this beaker. And then I will add a quarter of a spoon with calcium chloride to this beaker and stir. This calcium chloride dissolves much more easily than the alginate, so you will only need a couple of minutes and it will be dissolved. Of course, while you are stirring, you may ask them, why is it smart to use hot water instead of cold water when we dissolve stuff, and make them reflect on that. And try to help them realize that in hot water, the water molecules move much faster than in cold water, and this helps to tear the molecules you're dissolving apart. There's just more movement here, more activity in the hot water. So, and of course here you also have to decide which color you want on your slime. And I have decided I want to have blue slime. So I now add some blue food coloring to my alginate, and stir to see if the color is bright enough. And I will say it looks really nice. So I'm happy with that. And I take one more look here on the calcium chloride, and it looks fine to me. So then I will start by making jelly pearls, and then I will use a pipette. And if they haven't used pipettes before, please show them how to squeeze here, dip it, and then let go, and you can see that the alginate enters into the pipette, and then you lift it up, transfer it here, and you press out again. And if you push out now droplets, they will become small jelly pearls immediately. And if you let them stay here in this solution for a few minutes, they get quite strong. They don't break too easily. So of course, if they now have different colors, it's an idea to make them, if they want to have other colors, they can share with each other. Actually, I think it wasn't blue enough. I want it a little bit bluer, so I add a little bit more blue here. It's of course also possible there to add red, and then you will get purple. So that's a possibility. But and if I squeeze quickly, I will get long worms instead of alginate. That's also a possibility. It's important to not dip the pipette down in the calcium chloride solution, because then it will be, the alginate will be fixated inside here and you can't get anything through. And now I can take up some of what I've made, and it's nice to have a piece of aluminum foil to put it on. And as you can see here, really nice slimy stuff. And here we then have a chemical reaction, combining two types of molecules, creating something new. And of course, if you get impatient, it's also fascinating to pour directly to get really thick worms. But I will not take it up immediately because it needs a little time to make the calcium chloride really fixate the alginate here. So stir a little, and then I can pick it up. And it looks quite cool actually. Here you go. Nice slime. In this activity, you have enough reagents to do it one more time. So that's up to you if you find time for it. Good luck.